So we've got a 6-mark reversible reaction question here. It's going over a couple of pages. In the production of nitric acid, ammonia is first reacted with oxygen to form nitrogen oxide. The reaction is reversible. The energy change of the forward reaction is minus 904 kilojoules per mole. And in the previous question, we decided that meant the forward reaction is exothermic. So let's write that on the arrow. If we were to maximise the yield of nitrogen oxide, so in other words, push the equilibrium this way if we can, in this reversible reaction, what conditions would we choose and why? So first condition we've got to choose is either excess oxygen or add water. So do we increase the amount of oxygen or do we increase the amount of water to try and get more nitrogen oxide? Well, when altering the yield of a reaction, we've got 3 rules we have to remember. And this first one is rule 3. Increasing the concentration of a substance moves the equilibrium to the other side. So we want to therefore increase the amount of oxygen because that will push the equilibrium to the right-hand side. So we're going to say excess oxygen. And the reason, all we need to do is write this rule out word for word. Increasing the concentration of a substance moves the equilibrium to the other side. So increasing the concentration of a substance moves the equilibrium to the other side. You can write that in your own. I'm not going to write it all now. Next one. Temperature of 900 degrees or room temperature. Okay, so the forward reaction is exothermic. The rule: increasing the temperature on a reversible reaction favours the endothermic reaction. So if the forward reaction is exothermic, the backward reaction will be endothermic. So increasing the temperature favours the endothermic reaction. So what we need to write here is decreasing the temp will favour the exothermic reaction, or the Ford's reaction in this case. Okay, so that's all we're doing there again is just writing out the top rule here. Increasing the temperature favours the endothermic reaction, but we've said decreased temperature favours the exothermic reaction. So if we want a high yield therefore we're going to do it at room temperature. The downside with that, of course, is it will be slow. That would be slow. A compromise. Medium temperature would increase the rate. So very high temperature, you get it very fast, but the yield would be so low it wouldn't be worthwhile. Last one, 7 atmospheres pressure or atmospheric pressure. So are we going to increase the pressure or decrease the pressure? So we need the pressure rule. Increasing the pressure favours the side of the reaction with fewer gas molecules. So let's just write that in straight away. Increasing the pressure favours the side with fewer gas molecules. So we need to count the molecules. Okay, here's our reaction here. So to count the molecules, we count the stoichiometry numbers, the balancing numbers. 4 molecules and 5 molecules on the left. 4 and 5 make 9. 9 molecules on the left. 4 and 6 on this side make 10. So there's 10 molecules on the side. So there's fewer molecules on the left-hand side. So increasing the pressure favours the side with fewer gas molecules. There are 9 molecules on the left and 10 on the right. So increasing the pressure is going to reduce the yield because there's less molecules on the left. Increasing pressure reduces yield. So ideally then, atmospheric pressure would give us the highest yield. Would of course decrease the rate, so we may again want to compromise. So increase the pressure a bit to speed it up, but that would reduce the yield. All these questions on elshramhighchemistry.com.